Hello guys, welcome back to my channel, Engineering Chronicles of Plant Design. So let us continue with the design of pressure vessel as per ASME Section Division 1. So in the previous video, if you see, what we have done is we have said that the small opening, which is 88 mm in the diameter, the OD of the neck, if it is 88 mm, when the shell thickness is around 10 mm, or when the diameter of the OD of the neck, that is the nozzle neck, is around 60 mm, and if the thickness of the shell is more than 10 mm. In both the cases, reinforcement pads are not required, or to check the adequacy of the reinforcement is not required. But what if the diameter is more? Okay, so what normally we think is, we say that normally what we say is, no, if the diameter is more, we have to put the reinforcement pad. So that is not the case always. So what we have to do is, we have to check whether without the reinforcement pad our nozzle is adequate, design is adequate or not. So to check that, what we say is, we check the area replacement factor. So what is area replacement factor? So whatever area which we have removed from the shell, we have to say that this is adequate enough to hold the internal pressure or the design pressure, correct? So for that, there is a formula. The formula is AR is equal to D TRF plus 2 TN TRF in bracket 1 minus FR1. So what is D? D is the diameter of the nozzle neck. Okay. What is TR? TR is the required shell thickness for internal pressure. Okay. So required shell thickness. No, don't confuse. So for example, if a shell thickness is 10 mm, but required is only 8.5, so don't take TR as 10 mm. TR has, which will be 8.5 only. So F is a directionality factor, which we normally take from UG37 figure, UG37. But for all the cases, F is equal to 1 is what we usually take. Okay, only the case where the angle of the we will see that in the next week, in the next slide, in the based on the picture of UG37, what are the factors due to which the value of F can go down. But normally, please remember, the value of F is always taken as 1. So what is FR1? FR1 is the ratio of allowable stress of nozzle neck material to allowable stress for the shell material. That is FR1. FR1. So FR1 will be, for example, this is stress value of nozzle neck. So the stress value of nozzle neck N divided by stress value of shell, stress value of shell SS. So what we have to do is always select a nozzle material which has the greater allowable stress value than the shell. So what will happen in that case? This value will become this value will become 0. Will become 0. Will be negligible. So area replacement will be only depending upon this factor. Okay, so your air replacement value will come down, and your neck will be adequate enough to take the internal pressure. Okay, so don't remember always, whenever you're taking the nozzle, select the nozzle material which has allowable stress value equal to or more than the allowable stress value of a shell. Okay, it is not compulsory that you take in such cases, but it is a good engineering practice. But what if you take more? Do you have any consideration engineering? No, that is no. If you see, I've put here, there is no credit, but it is a good engineering practice. Okay, so TN, TN is the actual nozzle neck thickness, actual nozzle neck thickness. Okay, so moving on to the next slide. So as I said, this is figure UG37. So this is the longitudinal line shell axis and the value of theta. Depending upon the angle, the value of f changes. Okay, that's f changes. This is the angle and this is the value. You see this curve. So based on this curve, the value will change. If the value is 0, if it is 1, f is 1. If the value is 50-degree angle, then the f will be 0.7. But a value of 1 shall be used in all the cases except for inherently reinforced opening in cylindrical or conical shell section. Normally we use the value of f as 1 only. Only in the case where there is an inherently reinforced opening, then only we go ahead with this chart, and we continue to take the value of f based on this curve. Okay. So if you go and see the figure UG37.1, so this UG37.1 shows this you see this is the nozzle neck. Okay, this is nozzle neck. This is reinforcement pad. This is the shell, the vessel, the vessel shell. The normally shell what we say. Okay, so this based on this only we define the area replacement. So I'll go to next slide directly. I'll not talk more on this. I'll just go to, if you see this area, this is the area what you have removed. Okay. So for this only we check the area replacement is okay or not, right? So if you go to next slide, okay, it's a continuation picture only. I have taken the two slides. So don't go to a conclusion directly that you have to use reinforcement pad. First, you check this is the area of replacement formula. You check A1. There is two formula. So area available in shell, use larger value. You check both the formula and take larger value. A2, area available nozzle projecting outward, use smaller value. Both of these formula use smaller value. And in this use the smallest value. Okay, and the weld, then you take weld thickness. If you add A1, A2, A3, A41, A43, if this value is more than the area replacement value, then your reinforcement pad is not required. Understood? Reinforcement pad is required only when if you add this value, if it is less than the area replacement, only in that case your reinforcement pad is required. Or what you do again, you increase the thickness, the shell thickness, or you increase the neck thickness, and you continue with this calculation. Otherwise you can put reinforcement pad and you can continue this with this calculation. Okay, so in both the cases this is what you have to do. And if you find the area is adequate enough, don't put reinforcement pad initially. But if you feel this is less than this value is less, then two things you have to do. Either you increase the nozzle neck thickness, or you go with the reinforcement pad. Okay, there is a limit of reinforcement. So what is the limit of reinforcement? I'll draw and show you. In the previous picture also you can see, for example, this is the shell. Okay, this is shell, for example, and you have nozzle here. This is nozzle neck. This is the flange. This is a flange. Sorry, my drawing is not so good, huh? This is nozzle neck. Okay, this is nozzle going inside, and you want to put reinforcement pad here. This is the reinforcement pad. So this is the welding. This is the what we call fillet weld. Okay, I'll change the color now. So this value. So this is called, this value should not exceed. What it should not exceed? This is called limit of reinforcement. So what is limit of reinforcement? If you draw this axis, so what you have to check, diameter of the finish opening. So this value, I'll change the color again. So this value, you see this value should not be more than the diameter of the finish opening, or radius of the finish opening plus shell thickness plus T plus the neck thickness of the neck. This should not, whatever the greater value, take this. So greater value should not exceed the reinforcement. This should not exceed. This is what we call as limit of reinforcement. Okay. I'll not explain this in much detail, but we have one more option, which is division 2. We can apply the formula of division 2 in division 1 by using appendix 46. I have said this earlier also. Okay, so large opening reinforcement. So what is large opening reinforcement? So for example, if your cylindrical shell diameter is 60 inch in 60 inch, and your opening is 1/3 of the diameter of the ID, or but less than 20 inch. Or the next case is if the shell diameter is more than 60 inch, 1/3 of diameter of the vessel, or but less than equal to 40 inch. In both the cases, in both of these cases, what will happen is you have to go to the additional mandatory appendix 1-7A. Mandatory appendix 1 7A. So you have to also check the reinforcement requirement based on, if you go to the appendix this 1-7A, and you have to also check this requirement additional to the area replacement when your when your opening falls into this category into this category. Okay, so other next is if the diameter of the vessel is more than 60 inch or the finish opening is more than 40 inch and more than 3.4 root RT. Okay, in this cases, in this on the ratio of Rn by R, Rn is the radius of the nozzle divided by radius of the vessel is 0.7. Then in that case you have to go to 1-7b also. Okay, if the vessel falls into this category, this category, please also go 1-7b. Okay, so I think this is all about the reinforcement, nozzle reinforcement and nozzle uh, what we say, the reinforcement pad, how to select the reinforcement pad, what are formulas required. This is all about this. This video is all about that. Uh, I hope I have given you enough information. So please stay tuned and don't forget to give a like on the video, share my video to your friends as much as possible, because this is all knowledge sharing sections. May someone may get benefit of it, and don't forget to subscribe to my channel. I'll keep putting videos like this, and I'll keep sharing my knowledge to you people. So thanks a lot. Have a good day. Take care. Bye bye.